Completing the square part 1. This video will show you what it means to complete the square and also how to describe how to do it. You'll also learn how to solve quadratic equations by completing the square and finding square roots. So to complete the square, it means that we're going to add a constant term to a quadratic expression to form a perfect square trinomial. So this is how we will complete the square. We'll start with the example x squared plus 6x equals 7. The first step is to start with an equation in the form x squared plus bx equals c. This just means that we want the constant on the right side of the equal sign. Our equation already has the constant on the right side, so we can go to step 2. And step 2 says that we need to find the value that completes the square. And this is going to be our b term divided by 2, and then we're going to square it. So in our example, our b value is the coefficient of x, so ours is 6 for this example. So we're going to use our formula of b divided by 2 and squaring it. So we'll replace b with 6. 6 divided by 2 will be 3, and 3 squared gives us 9. So once we find that number, we're going to add this to both sides of our equation. So we're going to add 9 to both sides of this equation. So we can simplify 7 plus 9. That would give us 16 on the right side. And on the left side, step 4 tells us to rewrite the left side as a squared binomial. So we need to decide what number was squared to get 6x and 9. So it looks like 3 because we can multiply 3 by 2 to get the 6, and we can square 3 to get the 9. So now we have x plus 3 squared equals 16. So step 5 is to solve with square roots. So we're going to take the square root of each side, and the square root of that x plus 3 term that's being squared will just give us the parentheses of x plus 3. And then if we find the square root of 16, we'll get positive and negative 4. So since we can have a positive or negative, we're going to set up two equations. One is set equal to positive 4, and one is set to negative 4. So to solve for x, we'll subtract 3 from each side. So we get x equals 1. And on the other equation, we'll subtract 3 again. And this time we'll get x equals negative 7. So the answers of 1 and negative 7 would be the solutions to this quadratic equation. Let's try another one. So step 1 says to start with an equation where the constant is on the right-hand side. So since we don't have the constant on the right side, we'll do that first. So let's add the 13 to both sides so we can move it over. Okay, now that that's done, we'll go to step 2. So we need to find the value that completes the square. So we'll take half of b and square it. Our b value is 12 for this example. So we'll take half of 12, which will give us 6, and then we'll square it, giving us 36. Now the next step is to add this number to both sides of the equation. So we'll add that to both sides. We can simplify 13 plus 36. That would give us 49. On the left-hand side, we're going to rewrite it as a squared binomial. So we need to find what number times 2 would give us 12, and what number times itself would give us 36. That number would be 6. So we can rewrite that as x plus 6 squared, since we would get the same equation we started with. Now the last step is to solve with square roots. So we'll take the square root of each side. X plus 6 squared, if we take the square root, we'll only have the x plus 6. And then the square root of 49 is positive and negative 7. So now let's set up our two equations, one to positive 7 and one to negative 7. And we can solve for x by subtracting 6 on both sides. So we'll get x is equal to 1. And on the last one, after subtracting 6, we'll get x is equal to negative 13. So let's look at a few more examples using this completing the square method. So what could be added to each expression to make it a perfect square? So we're just trying to find the value of half of b squared that allows us to make a perfect square. So in the first example, we'll start by taking half of b and squaring it. In this example, b is 12. So half of 12 is 6, and 6 squared is 36. So if we that one didn't have a constant, so we can just add the 36. But with this one, the second example, they have a constant of 1. So after we find the value that makes it a square, we'll take into account that 1 that they already have. So let's get our equation, and b in this example is -6. So half of -6 is -3, and -3 squared is 9. So we want to add 9 to it, but it has that 1 there, so we only have to add 8 to get the 9 that we want. Now in the next example, it also has a constant term of -10 already, so we'll still find the value, and then we'll take into account that -10 at the end. So half of b in our case would be half of 14, which would give us 7, and then if we square that, we get 49. So we want to add 49, but it already has a -10. So we're going to have to add 59 so that when we subtract the 10 that's there, we'll get the 49 that we need. Let's look at some practice problems. We're going to add the number that would make the expression a perfect square, and then we're going to write it in factored form. So it's like the last example. We'll find that term, and then finally we'll make it into factored form. So for x squared minus 4x, we need half of b again. So in this example, b is -4. So half of -4 is -2, and -2 squared gives us +4. So we'll add that to our expression. And then if we want to rewrite it in factored form, we need to find what number times 2 would give us -4, and what number times itself would give us +4. So in this example, it would be -2, since -2 times 2 is -4, and -2 squared gives us that +4. So we can actually always find out what number should go into the parentheses by just taking half of our b term. So we'll practice that in the next example. So for x squared plus 2x, we'll write down our formula, and then we'll replace b with 2. So half of 2 is 1, and 1 squared is still 1. So we'll add that to our equation. And like we said, to find the factored form, we just need to find half of b. So in this case, it would be 1. So we'll have x plus 1 squared. Now we have x squared plus 14x. So we'll take half of 14, giving us 7, and then 7 squared gives us 49. So we'll add that to our equation, and then half of the b, which would be 7, will be our parenthesis value. And then we have x squared plus 24x. So we'll take 24 divided by 2, which gives us 12, and 12 squared is 144. So if we add that to our equation, we can rewrite this in factored form as x plus 12 squared. Here's another problem. So this time we want to rewrite each expression so that it contains a perfect square. So we'll do basically the same thing we did in the last example. So we'll start with the first problem, and we'll take our formula of b divided by 2 squared. In this example, b is 8. So half of 8 would give us 4, and 4 squared gives us 16. So we'll add that to both sides of our equation. 2 plus 16 could be simplified to just 18. And then we want to write x squared plus 8x plus 16 in factored form. So we know that something's being squared because we made it that way. So to find that number, we just take half of b. So this is equal to x plus 4 squared. Now let's try the second example. So we'll take half of b, which in our case is 10. So 10 divided by 2 is 5, and 5 squared is 25. So we'll add that to our equation. -13 plus 25 on the right side can be simplified to 12. On the left side, we want to make it a perfect square. So we'll take half of b, which is 5, so it will be x plus 5 squared equals 12. Now let's do the third example. So we'll use our formula. We'll take half of -14, which gives us -7, and -7 squared gives us +49. So if we add that to both sides, we can simplify the right side of the equation by adding 5 and 49, which gives us 54. And on the left side, we need to find half of b, which would be -7. So this is equal to x minus 7 squared is equal to 54. Let's try that last one. Okay, so we're going to take half of b, which in this example is 2. So we get 1 squared, which is still just 1. So if we add that to both sides of our equation, 0 plus 1 is still just 1. On the left side, we need to make it in factored form, so we'll write it as x plus 1 squared equals 1. Okay, one more set of problems. So this time we're going to solve completely. So we'll find our value, we'll make it a perfect square, and then we'll solve it. So x squared minus 6x plus 5 equals 12. So first we need to make sure the constant is on the right-hand side. So we need to move that 5 over. So if we subtract 5, we'll get x squared minus 6x equals 7. So now we need to find the term that will make this a perfect square. So this is when we take half of b and square it. So half of negative 6 is negative 3, and negative 3 squared is positive 9. So let's add that to both sides of the equation. On the right side, 7 plus 9 can be rewritten as 16, and on the left side it's going to be the factored form. So we'll take half of b, which is negative 3, and that's the term we'll be squaring. So now that we have this, we can start solving. So we'll take the square root of each side. So we'll get x minus 3 is equal to positive and negative 4. So we'll set up two equations with one being positive 4 and one negative 4. So we can get x by itself by adding 3 to both sides. So we get x is equal to 7. And then we'll add 3 again to the other equation, and this time we get x equals negative 1. So now let's try that last problem. So it already has the constant by itself, so we're good with the equation setup. So we'll just find half of b and square it. So half of negative 2 is negative 1, and negative 1 squared is positive 1. So we'll add that to both sides. So 8 plus 1 can be simplified to 9, and then the left-hand side can be rewritten in factored form as x minus 1 squared. And now we can start solving by taking the square root of each side. So we get x minus 1 is equal to positive or negative 3. So now we can set up both equations, one positive 3 and one to negative 3. And we can get x by itself by adding 1 to both sides. So we'll get x equals 4 and then x equals negative 2. So to recap what we've learned, turning an expression into a perfect square can be a good way to solve a quadratic equation. We can do this by adding a constant to both sides of the equation to make it a perfect square. We can find the constant that we need to add by taking half of the b coefficient and then squaring it.